Algebra 1 students, and welcome back to your Semester 2 final exam review. We're on to problem 53, which, at least for this year, hallelujah, is our last problem. And I get to be done making videos. That's so exciting. This problem comes from 10.6, which is where we did word problems with quadratics. So let's go ahead and read through this. The height h in feet of a person jumping off a diving board can be modeled by the equation h equals negative 16t squared plus 4t plus 6, where t represents the time in seconds the person is in the air. After how many seconds does the person jumping off the platform enter the water? All right, so just a pretty visual to get us started. We have xy axis. We know that we have a negative parabola. And we also have a person jumping off of a diving board. You might remember, and this isn't particularly needed for this problem, but it's nice to know, that the plus 6 at the end is our initial height. So I know it's also the y-intercept, that the person's starting on the diving board right here. And then visually, they're just going to jump up and down. However, this is going to be modeled by my negative quadratic that looks something like this. And you could put an arrow here, but realistically, we're going to be stopping just about here. So I guess it's water. They can go underwater, nothing bad. And the parabola technically goes back over here, but we don't need that because my input variable is t. So this is my t-axis, where t stands for time in seconds. Okay? So I don't want any of the numbers back here because these are all negative numbers, and negative time doesn't make a lot of sense if we're talking about when the person lands in the water. So what are we trying to find here? Well, after how many seconds, we're trying to find a time. Does the person jumping off the platform enter the water? Well, on my graph, where do they enter the water? That's right here. This is where they enter the water. And they enter the water at, what do we actually call the specific point? This is like our x, or in this case, our t-intercept. So how do we find t-intercepts? Well, every time we want to find a t-intercept, if you think about this point, this is going to be some t, comma 0. I think that we need to make the h 0, right? The time when a person enters the water is when the height is 0. So I'm going to set 0 equal to my equation, negative 16t squared plus 4t plus 6. All right. How do we solve this? Well, you could use the quadratic formula. Except if you look at the answers are all, I'm going to call these nice fractions. There's no weird square roots or weird decimals. So I'm just going to go ahead and I think use the box or factor here. It's so nice they give us a factoring problem to end. We're pretty good at that. Okay, so one way you could do this, I'm going to give you two different ways in just a second, but one way you could do this is just straight from the problem. We'd take negative 16t squared and 6. We know we need to break up the 4t, what plus what equals 4, and multiply the diagonals, okay? And using your calculator or some good mental math, 6 times negative 16, I think, is negative 96 t squared. 36, yeah, negative 96. So then we need to figure out what multiplies to make negative 96 and adds to make 4. And your calculator might come in handy here. This 4 isn't particularly helpful. I think it's going to tell us maybe the numbers are 4 apart, so I'm just going to start listing them, and this is how I do it with out of factor sheet. 1 and 96, those are not 4 apart. 2, let's see, 96 divided by 2, you can use your calculator on this one. I think that's going to be 48. Okay, then we try 96 divided by 3, and that's going to give me 32. And then we try 96 divided by 4, that goes in twice. 1 left over, 24. Those aren't 4 apart yet. 5 doesn't work. We know 6 works, right? 6 and 16. I should have made myself more space, so I will give myself more space. There we go. 6 and 16, but those aren't 4 apart. I don't think 7 goes in there, but you can check it on your calculator. We can try 8. 8, it goes into 96 12 times. Ha! We found it. 8 and 12. Those are 4 apart. That's my giveaway. So we know it's 8t and 12t, 8 and 12. And in order to make 4, I think the sign of the answer is always kept on the larger one. So that's 12, so we need to go like so. 12 minus 8 is 4. Negative 8 times 12 is negative 96. Good. Negative 8 and 12. And then we determine the outsides. So looks like these guys both have a negative and an 8 in common. Negative 8t times 2t is negative 16t squared. Negative 8t times 1, 2t times 6. And the bonus box, 6 times 1 is 6. Sweet. All right, looking good so far. What have we done? Well, we put our equation into factored form. So my factored form, and we're going to just look at it over here, is negative 8t plus 6 and 2t plus 1 still equal to 0. The reason that we had to use the box here is because there were two different types of t's. We couldn't use SADMAP, so we put this into factored form, and now we can make two equations. One equation, negative 8t plus 6 equal to 0. This is our zero product property. 2t plus 1 equals 0. Let's go ahead and use SADMAP to solve each one of these. I'm going to subtract 1 over here. That leaves me with 2t equal to negative 1. And on this side, of course, we would subtract 6. Negative 8t equals negative 6. Not done yet. There's still a number attached to t, so we'll divide off that negative 8. And this side we'll divide off the 2. On both of these, I don't think the denominator goes nicely into the numerator, but a negative divided by a negative, I'm pretty sure that's a positive 6/8. And over here, negative 1/2. So I have two answers, 6/8 and negative 1/2. If we look up above, negative 1/2 is here, but I don't think that makes sense. They want to know after how many seconds does the person jumping off the platform enter the water. Negative 1/2 would be like where they were before they got on the diving board. That's moving back in time. That's this spot right here. And so we don't want to move back in time. Instead, we want to figure out moving forwards in time. Now the problem is I got 6/8 moving forward in time, and none of these are 6/8. Oh, but wait, couldn't we reduce that fraction? I think 6 over 8, if you divide the numerator and denominator by 2, we get 3/4. And I think 3/4 is an answer. Whew! That was a close one. Now, I have two other tips and tricks for you for this problem. My first tip or trick is actually very similar to problem 52. Hopefully, you noticed in this equation that there is something common to all three terms. So I'm actually going to show this off on the side over here. So we had 0 equal to negative 16t squared, I want to make sure I get this right, plus 4t plus 6. Notice that you could have factored out a 2, or I think even better, a negative 2 from all of these. I always like to make my first term positive. It's just personal preference. You don't have to do that. That gives me 8t squared divided by a negative, negative 2t minus 3. And now, when you use the box, just focus on your easier numbers. 8t squared, negative 3. Okay, we're going to need to split up the negative 2t. So what plus what is negative 2t? And what times what? Look at how much nicer this number is negative 24t squared. Way easier to find factors of 24 than 96 and have to write them all out like that. To find factors of 24, well, they're going to be 2 apart, and I happen to know that 6 and 4 make 24 when you multiply, and they're 2 apart here. We'd need to give the 6 the negative. That's the only way you'll make negative 2t. And now we find the outsides. These guys have a 2t in common. So do these. Negative 3, positive 2, bonus box. I definitely messed something up. That's awkward. Oh, haha. That's silly. This should have been a 4, huh? 2 times 4 is 8. Whoopsies. And 4t times 1. Hopefully you caught that ahead of me. Woof! I guess I'm tired here. So, 0 equals negative 2, and then let's do our two sets of parentheses. 2t plus 1 and 4t minus 3. Now make your two equations both equal to 0. 2t plus 1 equals 0. 4t minus 3 equals 0. And by going through SADMAP, and I don't need to take you through it again, we've already done it once, this time you'll get 3/4 and negative 1/2. You don't even have to reduce, which is pretty cool if you take out that negative 2, and so we can see our answer is 3/4. Now, one other tip. I promised you 2 tips and tricks. This is our last one, so stay with me, promise. This 3/4 is pretty easy to check as an answer. You could actually do this for all of these. I'm just going to take 3/4. You can find it as a decimal, 0.75, and I'm just going to use my calculator quickly. And I'm going to see what happens if I put that 0.75 in for my t. Right, 0.75 plus 6. If you put all of this into your calculator, what should you get as an answer? Well, we set the equation equal to 0, so we better get 0. And in fact, using your calculator, you get 0. So that is a really nice way to check your work at the end, right? If you have a little bit of extra time, take your answer, put it in for the x's or the t's, the inputs, and make sure you get the output that you were expecting. And in this case, you will. So, thank you for making your way through this playlist. Hopefully these videos help you feel prepared for your Semester 2 final. If you really want to feel prepared, you should go back through every problem, cover up the work, and if you can explain to a friend, and I'd say under 10 seconds or so, how to do each problem without looking at your notes, then I think you're prepared for the final. However, if you can't, if you need to pause, like, oh, I don't really remember this one, then you're not prepared. Every problem under 10 seconds. Then you're prepared. So, as always, leave some comments if you need anything else or if I made any too crazy of mistakes. Thank you again, as always, for tuning in, and hopefully this semester treated you well.